Now let's look at network analysis in a practical context. So preparing feature classes and datasets sources. So here, for example, we need to have a feature class that has edges and junctions and potentially turns. These are again optional. Optional meaning that the network can be built and created without. It doesn't mean that they're not needed necessarily, right? So optional just means software optional. Not that they're not important or not needed, which is a very different thing altogether. So we need edges which connect junctions. And we can see example here in this little network data set. There's a little blow up of it there. Where we have the black dots, these are junctions. It's hard to see. And the edges are the red lines. And you'll see wherever two edges meet, there is a junction. And there are terminal junctions on many edges as well. So for example, a dead-end street, so to speak, would have a terminal junction on it. And so we need to have a data set that contains the edges as the source. So the main data layer feature class with edges. And the edges will be, we tell ArcGIS how to use the edges to create the junctions. And again, junctions are important in a network data set because they determine where you can change direction within the network when traveling through it, right? So at a junction point, you can either go in one direction or the other. You can't change direction mid-edge anywhere in a network data set. Also, if you are creating what's called a multimodal network, multimodal, that's a network that has a number of edge sources participating within it. For example, you might be considering modeling walkability in a network. Walkability requires that the agent walk from point A to point B. And we know that we can walk places where cars cannot drive, such as in parks, through trails, or along desire lines. Desire lines are those informal paths that often are shortcuts to get from one point to another that are not maintained by the city in any way. They are where people would like to have a path or something maintained by the city, but one does not exist for liability reasons. So a multimodal network can have something like paths, trails, streets, sidewalks. And when we have multimodal networks, we have to have junctions wherever one mode contacts another mode, if it is allowed at that location to change from one network to the other. For example, at the end of my street, there is a path that goes through a park. So if I had paths and streets in my network, then there would be a junction at the end of my street whereby street travel can go to park travel for walking, but not for driving, obviously. And so junctions are very important in that context. And so you need to consider that when creating a multimodal network. We will not be creating a multimodal network in this class. We'll just be using a straight single network edge source from streets. First, there's a number of new terms that you need to be familiar with in order to understand the way network analysis works. Firstly, we already mentioned an agent. That's something moving through the network. We have transportation networks in ArcGIS Pro, and these are things like roads, trails, walking paths, sidewalks, etc. that allow travel on edges, some in both directions, not necessarily every edge in both directions. Source features. Source features are line and point features that are used to create a network dataset. So a network dataset is something that must be created. It is not a simple feature class, for example. So just because you have a layer that has roads does not mean that that roads layer is a network dataset. It is a network, but it is not a network dataset. And we need to have source features. So the roads are actually source features upon which a network dataset can be built. And so the network dataset itself is what is used to solve network problems. It's a collection of network edges, junctions, other elements that model flow. Undirected flow, for example, or directed flow. Network attributes. These hold information about the network dataset, usually in the form of costs associated with traversing a network edge, such as distance or time. Descriptors, hierarchies, such as preferred road, and restrictions, such as one way. Some attributes, like network cost, must be present. So by default, network cost is distance on the network. But in a network, it's usually better to have time, because it's the time it takes to get from point A to point B that matters generally more so than the actual distance. So network cost by default is distance, but must be specified by the user if you're going to use time. Evaluators. These are network attributes, such as junctions, edges, turns, that determine how cost is calculated. So we might have, for example, evaluators to like speed, road speed, as a means to calculate time, travel time on a network edge. Since speed, right, speed equals distance over time. Network analysis layers contain a network analysis class. And these are things that include stops, routes, barriers, origins and destinations, analysis, which are analysis layers as well. And these are part of a network layer. Something, and this is separate from the network dataset. So it's something that is used to organize a particular analysis that utilizes a network dataset. So a network dataset is behind a network analysis layer. Turn. A turn is a right or left turn because they have different time penalties in a network. So a left turn takes longer than a right turn, for example. And by default, you can model turns, and it's a good idea. Even just to use the default turns, that the left will be a little bit longer than the right turns. And you may even have a network layer, or a network attribute, I should say, a network attribute that specifies how long turns take at a particular junction. And so that could be utilized if it is present. Now, there are a number of types of network analysis, and we'll look at each of these. We have best route, and this is something you're familiar with on Google Maps. Google Maps does best route, and it determines that through time, how long it's going to take to get from one place to another. And it would be best, if you're doing any type of best route analysis, to base it on Google Maps. Don't create your own network for it if you don't need to, because Google Maps has the best operational public interface to best route problems. Of course, these higher analyses we can't do on Google Maps. Vehicle routing and fleet problems. Well, some of them you can do if you pay for it and you know their API and stuff like that. Some you can't. So vehicle routing problems, closest facility, service areas, and very importantly, location allocation modeling. So when we have or we're ready to do some sort of analysis with a network, we have to add a network analysis layer. And these contain the classes such as stops, routes, or origins, destinations, any point barriers, line barriers, or polygon barriers to travel. So barriers are things you could put in, and we've seen barriers such as this street is closed, or construction is happening. That's a barrier, and these can be put in as well if you have that information. So each of these is a class, so a network analysis layer class. And that's what they're called. Before undertaking network analysis, we need to create a network data set. Unfortunately, we cannot create a network data set in ArcGIS Pro 2.4. The ability to create a network data set only arrived with ArcGIS Pro 2.5. We can undertake network analysis in ArcGIS Pro 2.4 as long as we have a pre-built network data set. And so part of each feature data set contains the built network data sets that I'll show you how to do in the next few steps. Because we need to do that in ArcGIS Desktop 10.6 or 10.7 or whatever, 10.4 even, 10.1, 10. They all have the ability to create a network data set. But it was not ported over to ArcGIS Pro until 2.5, which we don't have access to. The general steps in preparing a network data set are firstly to prepare the source feature classes. These are the feature layers that are usually a street network, trail network, walking network, sidewalks, etc., that participate within the network data set. So a network data set builds all those network tables like the adjacency matrix and everything based on the participating feature classes. And that requires preparing the sources that participate for their appropriate roles inside the network data sets. And that can include the creation of attributes, such as the time it takes to travel along each network edge, which may not be within the actual table itself. And so for the network source, we can create a new attribute that contains something like how long it would take to walk along a network edge, which is a street, for example, or a trail, anything that's part of the network. If we're creating driving network data sets, we may have to have a turn feature class as well, so that turn information can be provided to the network. Turns are exactly what they sound like when you make a turn driving. Why? Because a right turn is faster than a left turn. And so taking that into account is part of the modeling of a network data set in order to better approximate real-world conditions. Once you have prepared all of the participating feature classes, then you create the network data set using the new network dataset wizard in ArcGIS Desktop. Once you've built, or create, I should say, once you've created the network data set, you must build it. The building process is the process by which ArcGIS abstracts the network into graphs. Now, it doesn't actually make graphs like this. It just creates the tables, like we saw earlier, like an adjacency matrix, a distance matrix, etc., in special formats that we don't have access to and we don't actually see or use directly. It's all taken care of for us in the build process of the network. So let's look at a network data set for walking. So here we can see this example. We have walking paths and we have streets. So I guess what I meant by we're not going to use a very complex multimodal example in this module. We'll just use a simple one, which is paths and streets. And you can see where paths meet streets, just in this flashing little diagram here. So everywhere we have a flash or a red line intersecting a white line, we need to have junctions that allow travel to change between street mode and trail mode or path mode. So the first thing we do is we have to look at our source features for the network data set. We have paths and we have roads. And we look in each of these to see if there is a impedance attribute or cost attribute associated with each of the different edges. So here, for example, we have walk time and walk time in both of them. And walk time is given by this equation here. Time in minutes equals 60 times the distance in kilometers and the speed in kilometers per hour. So that then gives us the amount of time in minutes it takes to walk a given segment. We're assuming here a walking speed of 5 kilometers per hour. So not an overly brisk walk, but not an overly slow walk. And that is computed from just the length of each segment. So the first thing we do once we have those source attributes that will then become network attributes, like the cost or impedance, is we then create a network data set using the new network data set wizard. So in the lecture network geodatabase, I right click on the feature class, Ottawa roads, and then I say new network data set. And that brings up the network data set wizard. Then it asks me to give it a name. It asks me for the feature classes that will participate in the network, which are paths and roads. So it's good to have those in your map already, or you can they'll just come out from the database in which you're building the network in, so you'll see them there anyway. And then, do I want to model turns for walking? No. So right and left turns walking don't cost extra time. It's not the same as driving. So I don't want to model turns in a walking data set. And then connectivity. Connectivity is where we specify how or where walking can change from street to trail or trail to street. And when we click the connectivity button here, it opens up the connectivity dialog, and we just make sure that the policy is any vertex. Any vertex means any place that a trail and street meet together. If there's a meeting of those two things, there can be a change of mode from one edge source to another. And then we look at our network data set, and we want to model elevation, and we put none for walking. Now, for walking, generally you'd say yes, you want to model elevation, and you would use an elevation field. We'll see that later. Elevation here means underpasses or overpasses. So we might actually, when I do in the live example, I'll probably add elevation in there and utilize it. So in a network source, if you want to model elevation, elevation must be present. And here it doesn't mean meters above, it's just a means by which something tells, there's a field with a attribute that tells whether or not something goes over something else. In other words, if these two edges cross, should a junction be put there or not? Well, if elevation is modeled and the crossing of the two junctions is because there's an overpass and underpass present, then there will not be a junction put there because it's not a place where travel can change from one edge to another. And so elevation is very important to model in any real network data set. Otherwise, you end up with the ability, let's say, to for a person walking to end up walking right on the Queensway, or somebody driving to drive from one road right onto the Queensway, or the 417 we call it, or the 416, etc., which is not possible. It's only possible at certain junctions. So let's look at that in detail. So creating the network data set. So in the new network data set, it's going to ask us now to determine the attribute that we want for cost. And so the default again is length, but we want to put time. So we click add. Then we add the name walk time as a cost. We have to specify that's a cost attribute now. What its units are, minutes, and the data type, which will generally be double, something with decimal places. Then, once we add the attribute in, we need to add the evaluator for that attribute. So we go back once we have that attribute in there, then evaluator and attribute walk time. And what we specify here is the value over here and here. First we say field, and then we put walk time for all the values, all four values here, from to and to from. Then we click OK, and at that point we now have walk time as a valid cost for traversing edges. Then we click Finish, and it will take a second. It'll put in Ottawa roads and ask us to build it, and we say OK. If it doesn't ask you to build it, you can right-click on it and say Build. Building is important. It has to be done before it can be used in analysis. Now, also, if you go back into the properties after and you change anything, change a property or attribute, you must rebuild. So you need to know where to find that build. So if you go back later and decide you want to, let's say, model turns, for example, or use a different network attribute, you have to rebuild the network. And it can take a minute, for anywhere from a minute to longer, depending on the size of the network. We could calculate, for example, the alpha and gamma indices for a network. So both are quite high. So that we have a very connected network in Ottawa with many cycles in it. So many ways to get back to the same point without traversing the same edge, basically, within the Ottawa road network.